Jigsaw puzzles are great, especially when you finally put in the last piece. It is so rewarding. Complex numbers have been like that for me, and it was only recently, when I went on a deep dive into complex numbers, that I found out how important a piece they play in the puzzles of math, quantum mechanics and engineering. We'll explore this later, but first, what is a complex number? A complex number is any number that can be written as a real number plus an imaginary number. The real numbers are all the numbers on the number line, numbers that you know and have been working with previously. So numbers like 42, -6 and pi. The imaginary numbers do not exist on the real number line, but are the multiples of I. This means that if you square them, you get a negative number. This follows from I's definition, which is I squared is equal to -1, or put another way, the square root of -1 is equal to I. This property makes imaginary numbers different, as no real number squared can give a negative number. There's also an imaginary number line. This includes all the imaginary numbers, so numbers like 3i, -4i, and 1/2i. When you add the two types of numbers together, you get a complex number. So numbers like 3 plus 4i, 4 plus -2i, and -3 plus 1/2i are all complex numbers. There's also a complex plane. The complex plane is when you put the real number line and the imaginary number line together. The complex plane looks like a coordinate grid, where the x-axis is the real numbers and the y-axis is the imaginary numbers. The coordinates would be the complex numbers. So 3 plus 2i would be like the coordinate 3, 2, since the real part is 3 and the imaginary part is 2. How are complex numbers important in the three fields? In math, they are great tools, and they can make previously impossible things possible, like finding the answer to all polynomials. In electrical engineering, they used an equation, volts is equal to current times resistance. This is because the resistance of electrical components in an AC circuit behaves differently from each other. This means you cannot just add up all the resistance. You need to use the complex plane and complex numbers to be able to get the correct total resistance, also called impedance. In quantum mechanics, they used in Schrödinger's equation. Schrödinger's equation is essentially what allows you to know where the quantum particle you're looking for is likely to be. I hope I have piqued your curiosity and that you'll continue learning in this wonderful topic.